Listen. Just for a moment, silence everything else and just listen. That sound you're hearing isn't special effects. It was recorded in the deep ocean, at undisclosed coordinates somewhere in the crushing blackness of the Mariana Trench. It's a strange, haunting noise, isn't it? It has a metallic quality, like grinding gears from a sunken machine, yet it also pulses with a disturbingly organic rhythm, like a monstrous heartbeat. For years, hydrophones placed in the deepest, most remote parts of our world have been picking up sounds like this. They are a chilling reminder that in the 21st century, our planet still holds profound and terrifying secrets. Scientists, of course, have names for them. There's the bloop, an ultra-low-frequency roar that was detected by sensors over 5,000 kilometers apart. There's Julia, a mournful cry that lasted for 15 seconds, loud enough to be heard across the entire equatorial Pacific Ocean. Then you have upsweep, a long train of narrowband sounds that have been slowly decreasing in pitch since 1991. The acoustic signature of these recordings points to something living. They share the hallmarks of marine animal calls. But that's where the logic breaks down, and the mystery truly begins. The sheer power of these sounds is simply impossible. To be heard across such vast distances, the creature making them would have to be colossal, dwarfing anything known to science. A blue whale, the largest and loudest animal on Earth, produces a call that reaches about 188 decibels. It's a sound so powerful it can travel for hundreds of miles. But some of these unexplained noises are significantly louder, suggesting an animal of a size that, frankly, shouldn't exist. What kind of living throat, what kind of biological structure could generate a voice that powerful? It's a question that keeps oceanographers awake at night. Naturally, science seeks rational explanations. The official theory for the bloop, for instance, is that it was the sound of a massive iceberg cracking and breaking away from a glacier in Antarctica. It's a plausible, if somewhat less exciting, conclusion. But it doesn't quite fit the profile of all the other sounds. Some of them are too rhythmic, too structured to be the random chaos of geology. They sound less like ice breaking and more like a signal or a warning. They sound deliberate. It feels as if something down there is trying to communicate, and we're left staring at our instruments, wondering what it's trying to say. Imagine where these sounds are born. They emanate from the Hadal Zone, the deepest trenches in the ocean, a realm beyond 6,000 meters. Down there, the pressure is over 1,000 times greater than at the surface, an incomprehensible weight that would crush a military submarine as if it were a soda can. Sunlight has never once touched this world. It is a place of absolute darkness, freezing temperatures, and crushing force. Life here is already alien, having adapted in ways that seem to defy biology. This isn't just another habitat. It's a separate world, governed by its own brutal rules. Our fascination with the abyss is primal. It is the last great unknown on our own planet, a dark mirror holding our deepest anxieties about what we cannot see. We can map distant galaxies, but we have explored less than 5% of our own ocean. That vast, watery emptiness is a perfect canvas onto which we project our fears of the monstrous and the unknown. And these sounds give that fear a voice. It's one thing to imagine a monster lurking in the dark. It's another thing entirely to hear it calling out, its voice echoing from a place you can never, ever see. For decades, whenever we've been confronted with a mystery from the deep, our imagination has raced backwards in time. We dream of living fossils, of creatures that somehow cheated extinction. Could it be a megalodon, the giant shark of prehistory, still hunting in the trenches? Or maybe a plesiosaur, its long neck snaking through the darkness? We look to the past because it's familiar territory. We secretly hope for a living dinosaur, a thrilling but understandable monster from a world we have already cataloged and understood. But what if we've been looking in the wrong direction entirely? What if the creature making these sounds doesn't exist? Yet, what if these anomalous recordings are not an echo from our planet's distant past, but a whisper from its coming future? This question changes everything. It reframes the mystery from a search for what was, to a terrifying glimpse of what will be. The ocean is not a static museum of life. It is a dynamic and violent laboratory. Evolution never stops, And in a world undergoing such rapid, radical change, the pace of that evolution is accelerating in ways we can barely comprehend. Perhaps these sounds are not the call of a single, undiscovered behemoth. Perhaps they are the birth pangs of a new form of life, the groaning and shifting of an ecosystem in flux. Think of it as the sound of nature's forge, the planetary-scale hum of DNA being rewritten under pressures we created. It's a chilling thought that the answer isn't a relic hiding in the dark, but a new chapter of life just beginning to be written. The sound isn't a monster. It's the noise of a monster being made, right now, in the deepest, darkest corners of our world. This leads us to a new, more urgent line of inquiry. If we want to decipher this message from the abyss, if we want to understand what is making these impossible sounds, we can't keep searching fossil records. We need to look at the world around us. We need to understand the brutal pressures, the toxic crucibles, and the chaotic new rules that are shaping life in our oceans as we speak. To understand what kind of life could be coming, we first have to face what we have done to its world. We have to look at the crucible of change because the future of the ocean is being forged there, right now. To understand what's coming, we have to face what we've done. Evolution, you see, isn't a gentle process unfolding over tranquil millennia. It is a war, fought on countless fronts, where the prize is existence itself. It's a relentless response to pressure. And for the last century, humanity has been cranking up that pressure to an almost unimaginable degree. We have transformed the Earth's oceans into a vast, planetary-scale laboratory for extreme adaptation. We've changed the rules of the game, and in doing so, we've lit a fire under the crucible of life. The question is, what will crawl out when the forging is done? Let's start with the most visible of our sins: plastic. When you picture the Great Pacific Garbage Patch, you probably imagine a floating island of bottles and bags. But the reality is far more insidious. It's less of an island and more of a thick, shimmering soup, a galaxy of plastic fragments stretching for millions of square kilometers. Sunlight and saltwater break down our trash not into nothing, but into smaller and smaller pieces, a ghostly confetti of microplastics. This synthetic dust is now one of the most abundant materials in the ocean, a permanent new sediment clouding the water from the sunlit surface to the eternal darkness of the deepest trenches. This plastic smog is everywhere, and in everything. It is inhaled by whales, mistaken for food by turtles, and consumed by the tiniest plankton at the very bottom of the food chain. From there, it works its way up, concentrating in the bodies of fish, birds, and ultimately us. We have introduced a completely alien, toxic, and non-biodegradable substance into every corner of the global marine ecosystem. In a world of scarcity, life is opportunistic. So what happens when this plastic becomes a new, inexhaustible resource? What happens when evolution starts to see our trash not as a poison, but as a building block? But the threats you can see are often the least frightening. Silently, invisibly, we are changing the very chemistry of the water itself. Every day, the oceans absorb about a quarter of the carbon dioxide we pump into the atmosphere. This creates a chemical reaction that is slowly but surely making the seas more acidic. In simple terms, we are turning the oceans into a planetary-scale vat of soda water. For countless organisms, from the corals that build vast reefs to the tiny pteropods that are a vital food source, this is a catastrophe. Their shells, the very homes they build around themselves, are becoming harder to form and are literally starting to dissolve. Imagine being a creature whose skeleton is on the outside and learning that the world itself is becoming corrosive to your very bones. This is the slow-motion horror facing a huge portion of marine life. At the same time, the fertilizers and waste from our farms and cities wash into the sea, creating terrifying explosions of algal blooms. When these blooms die and sink, their decomposition sucks all the oxygen out of the water, creating vast, dead zones. These hypoxic expanses, some the size of small countries, are silent underwater deserts where most life suffocates and dies. Only the most bizarre and resilient organisms can eke out a living in these toxic, breathless voids. And just when you thought we couldn't be more disruptive, we decided to invade the last pristine wilderness on Earth, the deep sea. For millennia, the abyss has been a realm of absolute stability, defined by crushing pressure, freezing cold, and eternal darkness. Now, remote-operated machines are descending into that blackness, their floodlights tearing through the dark, their grinding drills searching for precious metals. These deep-sea mining operations are a cataclysmic event for ecosystems that have evolved in near-total silence and stillness for millions of years. It's an earthquake, a volcano, and an industrial revolution all at once, unleashed in a world that has never known such chaos. The sediment plumes kicked up by this mining can travel for hundreds of kilometers, burying fragile deep-sea corals and sponges that may be thousands of years old. The noise and light pollution are a form of sensory warfare against creatures who navigate by faint bioluminescence and subtle vibrations. We are fundamentally rewriting the environment of the one place on Earth that had, until now, remained untouched by our influence. We are introducing fire and fury into a world of cold, quiet dark. In our relentless hunger for resources, we are creating new pressures in the very places where life is already at its most extreme. So, let's take stock. We have an ocean being choked by a new, synthetic sediment of plastic. Its very chemistry is becoming corrosive, dissolving the shells of its inhabitants. Vast stretches are being starved of oxygen, turning them into suffocating dead zones. And its deepest, most ancient sanctuaries are being violently shattered by our machines. This is not the ocean of David Attenborough documentaries. This is a new ocean. A hostile, toxic, and radically different world from the one that life has been adapting to for the last billion years. Evolution is an arms race, but we've thrown a chaotic jumble of new weapons onto the battlefield. We've introduced poison shields, acid sprays, suffocating clouds, and weapons of sensory overload. This is the new environment. These are the new rules. Life, in its desperate, relentless drive to continue, now has a stark choice. Adapt to this new hellscape in radical ways or perish. And life is the ultimate survivor. It will not perish. It will change. The adaptations born from this brutal, chaotic new world will be as extreme, as alien, and as terrifying as the conditions that created them. This isn't a distant future scenario. This is the reality that is unfolding beneath the waves right now. We have created a global crucible, a high-pressure laboratory for mutation on a scale not seen since the last mass extinction. The engine of evolution is now running white-hot, fueled by our own actions. The results will be strange, they will be monstrous, and they will be magnificent. The time for gentle adaptations is over. The age of monsters is beginning. So, in an ocean of plastic and poison, what kind of hunters will emerge from the darkness? In a world poisoned by our own hand, what kind of hunters emerge from the darkness? When the traditional food web is shattered and replaced by a chaotic scramble for survival, the predators that rise to the top won't be the ones we know. They will be new apexes, forged in a crucible of plastic and chemicals. They will be faster, tougher, and more cunning. Their very biology twisted into new and terrifying shapes by the unnatural pressures of their environment. These are not creatures of natural selection in the classical sense. They are the products of an unnatural one, and the first glimpses are already haunting the imaginations of biologists. Imagine a great white shark, already a near-perfect predator. Now, imagine it swimming not through clear blue water, but through the thick, shimmering soup of the North Pacific Gyre. For generations, its ancestors have been swallowing microplastics, the toxic material building up in their tissues. But evolution is relentless. A mutation appears. A new kind of bacteria in the shark's gut allows it to not just tolerate plastic, but to metabolize certain polymers. This isn't just about survival anymore. It's about opportunity. Our trash has just become a source of biological material. Meet the plastivore shark, a hypothetical apex predator for the Anthropocene epoch. Its most terrifying feature is its hide. The shark's famous dermal denticles, the tiny tooth-like scales that make its skin a hydrodynamic marvel, have changed. They are now infused with polymer composites, bonded into a nightmarish form of biological armor. This hide is unnaturally smooth, allowing it to slice through the plastic-choked water with terrifying efficiency. And it's incredibly durable, capable of deflecting the bites of rivals or the desperate struggles of its prey. It is a hunter literally armored in our waste. His teeth are no different, constantly regrown. They incorporate the sharpest, hardest polymer fragments, giving them a serrated edge that never dulls, always retaining a razor sharpness that flesh and bone cannot withstand. This creature doesn't just live in the garbage patches. It is a physical manifestation of them. It stalks the ghostly underwater blizzards of microplastics. Its senses fine-tuned to detect the faintest movements of fish whose own bodies are riddled with our synthetic legacy. What hope does prey have against a hunter forged from the very trash that chokes its world? But brute force and armored hides are only one path of evolution. In the murky, polluted waters of the future ocean, deception may prove to be an even deadlier weapon. Predation is often a game of cat and mouse. But what happens when the cat can disguise itself as the only cheese the mouse has learned to eat? The result is a trap so perfect, so diabolical, that it represents a new pinnacle of evolutionary cunning. It's a predator that kills with a silent, beautiful lie. Picture a jellyfish, drifting not in a vibrant coral reef, but in the polluted coastal waters near a river mouth. It's huge, larger than any known species, and it glows with a soft, internal light. But this is no ordinary bioluminescence. It flickers and shimmers with an oddly familiar pattern, mimicking the way sunlight reflects off a submerged plastic bag caught in the current. This is the lure jelly, and its glow is a siren song for the desperate. In this toxic estuary, many species of fish have adapted to eat the abundant plastic debris. For them, that synthetic shimmer means food. The lure jelly has turned their adaptation into a death sentence. As a school of fish, drawn by what they believe is a meal, swarms closer, they brush against its trailing tentacles. These are not ordinary stingers. They are coated with a neurotoxin of breathtaking potency, refined over generations to be instantly lethal to creatures with plastic-laced physiologies. The trap is sprung in silence. The mesmerizing light flickers over the paralyzed bodies of the fish as the jellyfish slowly digests them. It is a form of aggressive mimicry so specific, so perfectly tailored to our polluted world, that it's both a biological masterpiece and an ecological nightmare. The horror of the lure jelly isn't just its existence, but the perverse causal chain that created it. We introduced the poison, the plastic. Evolution, in its desperate bid to survive, produced creatures that could eat that poison. And then, evolution produced a predator that mimics the poison to hunt those creatures. We are not just bystanders to this horror. We are its architects. We designed the bait, and nature simply designed a better trap. It's a chilling testament to life's ability to turn even our greatest mistakes into a weapon. The plastivore shark and the lure jelly are just two possibilities, two nightmarish branches on a rapidly growing evolutionary tree. They represent the arms race of predation, the endless cycle of hunter and hunted, now accelerated and twisted by the new reality of our oceans. As predators become more formidable, prey must become more elusive, driving both down ever more bizarre and specialized paths. This relentless conflict is a powerful engine of change, responsible for some of the most incredible diversity we see in nature. But predation is only one path. In the brutal arms race of evolution, sometimes the most successful strategy isn't to fight harder, but to stop fighting altogether. Sometimes the answer isn't to devour your neighbor, but to join them. What if, instead of individuals becoming stronger, entire communities began to act as one? What happens when the survival strategy shifts from conflict to cooperation on a scale never seen before? The next step in this strange future may not be to become a better monster, but to merge and become something vast, new, and alive. Something bigger. The arms race between predator and prey is a powerful engine of change, but it's not the only one. Evolution is full of surprising alliances, moments where the drive for survival leads not to conflict, but to cooperation. Sometimes the most successful strategy isn't to become a better killer, but to join forces, to merge, to become something more than the sum of your parts. What happens when this principle is pushed to its absolute limit? What if, instead of adapting to an environment, life begins to become the environment itself? The answer takes us from individual creatures to living worlds, born in the deepest dark and on the poisoned surface of our future ocean. Let's journey back down, past the twilight zone, past the realm of the monstrous hunters, and into the abyss. We're heading for the hydrothermal vents, volcanic chimneys on the seafloor that spew superheated, mineral-rich water into the crushing cold. On Earth today, these vents are oases of life in the desert of the deep, supporting entire ecosystems based not on sunlight, but on chemosynthesis. Bacteria thrive on the sulfur and chemicals, and in turn, they feed giant tube worms, ghostly fish, and strange crustaceans. But in a future ocean, a new kingdom of life might claim this territory. Fungi. Imagine a fungus, but not as we know it. This isn't a soft, carbon-based mushroom. This is a life form of silicon and crystal. In an environment with immense pressure and a constant supply of dissolved silicates and metals, evolution could favor a new kind of biology. These geothermal fungi would grow in vast, slow, geometric patterns, spreading across the seafloor like a living circuit board. They wouldn't just consume the chemical energy from the vents. They would be conduits for it, their crystalline structures capturing heat and minerals, pulsing with a faint, internal light. This is not a plant or an animal or a fungus. It's something new. This network would become the foundation of a truly alien ecosystem. It wouldn't be a creature living on the rock. It would be the living rock itself. Other, smaller organisms would evolve to live within its glowing, crystalline matrix, feeding on the energy it channels. Over millennia, it could grow to cover entire fields of hydrothermal vents, becoming a single, interconnected organism miles wide. It wouldn't have a brain or a nervous system, but it would react to its environment, growing towards new heat sources and repairing damage, a vast, slow, geological-scale intelligence. It's a form of life that borders on geology, a mountain range that is alive. Now, let's rise from that crushing, alien darkness and return to the sunlit, toxic surface. Here, a different kind of merging is taking place. We know of the Sargasso Sea, a real region in the Atlantic where massive mats of sargassum seaweed create a unique floating ecosystem. Now, picture that concept supercharged in a future polluted ocean. We're not talking about a mat of seaweed anymore. We're talking about the Sargassum Citadel, a floating island of life the size of a continent. This isn't just one species. It's a new form of large-scale symbiosis, a fusion of countless organisms. It would begin with a species of algae, perhaps one we accidentally engineered with chemical runoff, that is hyper-resistant to toxins and grows at an explosive rate. This algae forms the main structure, but woven into its fabric are other, stranger partners. Colonies of bacteria that have evolved to break down plastics and petroleum find a home here. They get structure, and in return, they feed on the pollutants, turning our toxic slicks into nutrients for the entire colony. But the true wonder is the scaffolding. Imagine mutated colonial animals like the siphonophores, creatures that are already made of many specialized individuals working as one. In the citadel, these organisms have fused with the algae, creating a tough, buoyant, and interconnected structural lattice. The result is a single, cohesive macroorganism. It's a floating labyrinth of living tissue, with channels for water flow, chambers for cultivating symbiotic bacteria, and a thick, iridescent surface that shimmers with an oily rainbow sheen. It's not just an island. It's a living city. This citadel is more than just a passive raft of life. It's an active participant in its environment. By metabolizing toxins, it creates a bubble of relatively clean water around and within itself, a sanctuary in a dying sea. This act of self-preservation makes it seem almost purposeful. There is no central brain, but chemical signals pass through the entire network, a slow, distributed consciousness that allows it to respond to its surroundings. If a new toxic spill approaches, parts of the colony might shift their metabolic functions to handle it. It is a semi-sentient ecosystem, a living place that actively fights for its own existence. From the crystalline fungal networks of the abyss to the continent-sized living rafts on the surface, the future of evolution may be one of immense scale. Life isn't just adapting to the world we've broken. It's rebuilding the world in its own image, creating new habitats out of its own body. These are not creatures you can hunt or capture. They are forces of nature, as vast and indifferent as a hurricane or a tectonic plate. They are a profound reminder that life, when pushed, doesn't just survive. It builds. The sheer complexity of these living systems is staggering. A network of crystal that thinks with geology and heat, a floating continent that manages its own chemistry. As life grows larger and more intricately connected, so do its interactions. But this raises a new, even more profound question. What happens when that complexity turns inward? What happens when a biological network becomes so dense, so interconnected, that it moves beyond slow chemical reactions and develops a new way to communicate, a way to think? What happens when the abyss learns to talk to itself? We have explored monsters made of our own trash and living continents born from our pollution. But perhaps the most profound transformation won't be in the body, but in the mind. We think of intelligence as something singular, a spark that lives inside a skull, behind a pair of eyes. It's the way we experience the world, as individuals. But what if that's just one model of consciousness? In the shifting, chaotic oceans of the future, a new kind of mind might be stirring, one that is not singular but plural. And the candidate for this evolutionary leap is already among us. A creature of alien intelligence and startling ability, the cephalopod. Octopuses, squid, and cuttlefish are the undisputed geniuses of the invertebrate world. They are master problem solvers, capable of navigating complex mazes, using tools and demonstrating what appears to be distinct personalities. A significant portion of their neurons are not in a central brain, but distributed throughout their arms, meaning each limb can think and act semi-independently. But their most dazzling ability is written all over their skin. I'm talking about chromatophores, the millions of tiny, pigment-filled sacs that allow them to change color and texture in the blink of an eye, creating camouflage so perfect it borders on magic. This ability is more than just mimicry. It's a language. Cephalopods use their skin to communicate with each other, flashing patterns of aggression, courtship, and warning. It is a vibrant, complex, and incredibly fast conversation. But right now, it's a language of simple statements. What if, under the immense pressure of a new, more dangerous ocean, that language was forced to evolve? What if the need for perfect coordination against new predators or for hunting in toxic, murky water pushed their communication to a level we can barely conceive of? Imagine a species of deep-sea squid. Isolated in the dark, their survival now depends on moving as one. Over generations, their chromatophores become more refined, more numerous. They evolve from simple color change cells into biological pixels, capable of creating incredibly high-resolution patterns of light. Their skin becomes a living screen. This is the birth of a biological internet, a network made not of fiber optics and silicon, but of flesh and light. Through rapid, complex flashes, they are no longer just saying danger or food. They are transmitting data. One squid at the edge of the shoal sees a plastivore shark approaching. It doesn't just flash a generic warning. In a fraction of a second, its skin ripples with a complex cascade of light that communicates the predator's size, speed, trajectory, and even its perceived intent. This pattern is instantly picked up by its neighbors, who repeat and broadcast the signal. Within moments, the entire shoal, spread over a square kilometer of black water, receives the full, detailed sensory report. They don't just react. They know. They are 1,000 bodies sharing a single point of view. This collective consciousness would redefine hunting. A single mind, acting through hundreds of bodies, could execute strategies of breathtaking complexity. Imagine a swarm of these creatures descending on a school of fish. Some units create a pulsating wall of disorienting light, herding the prey. Others, kilometers away but part of the same thought process, form a perfectly timed pincer movement, closing the trap. It would be a hunt of impossible precision, a silent, deadly ballet choreographed by a single, distributed intelligence. There is no leader. There is only the network. As this intelligence grows, would it move beyond simple survival? In the silent depths, free from the chaos of the waves, could it turn to creation? We might see hundreds of squid working in perfect unison, using their arms and funnels to move rocks and sculpt sand, building vast, geometric structures on the seafloor. Are these shelters? nests, or something far stranger. Perhaps they are a form of memory, a physical library. They might cultivate specific strains of bioluminescent bacteria, painting their collective history onto these structures in patterns of living light, a history book for a species that has no voice. This raises a deeply unsettling philosophical question. What is it like to be one of these squid? Is the individual animal conscious as we understand it, or is it merely a node in a network, a single neuron in a brain the size of a reef? If you were to remove one from the collective, would it be confused, lost, effectively lobotomized? Or would the collective intelligence simply route around the damage, the loss of one body as insignificant as a human shedding a skin cell? It's an intelligence so alien to our own individualistic existence that it borders on horrifying. And what does this silent, thinking network perceive of us? It would see the lights of our submersibles, feel the sonar pings of our ships, and register the seismic shock of our deep-sea mining operations. To this vast, quiet mind, we would be a source of random, violent, and incomprehensible noise. It would observe, it would learn, and it would do so in complete silence, its thoughts flickering as a language of light in a darkness we can't penetrate. A vast, intelligent system is growing in the abyss, aware of its world, aware of the changes, and perhaps aware of us watching it. This is the possibility of a mind that is not born but woven, a consciousness that emerges from the connections between individuals. A silent language of light, a living island made of fused bodies, a hunter armored in our own trash. The future of evolution is a gallery of the bizarre and the profound, which brings us, finally, back to where we started. Back to the sound, the mystery from the abyss. What if it's not the call of a single creature, but something much, much bigger? So now let's go back. Back to the beginning. Back to the darkness, and the silence, and the sound that breaks it. Listen to it again. Does it sound different to you now? That strange, pulsating, metallic yet organic noise. When we first heard it, it was simply a mystery, a ghost in the machine. We imagined a single, colossal creature, a lonely leviathan roaming the abyss, a holdover from a bygone age. But after everything we've considered, the armored sharks, the living islands, the networked mines, does the idea of a single creature still seem big enough to explain it? We have been looking for a monster, but maybe the problem is that we've been thinking too small. Our search has been limited by our own biology, by our experience as singular beings. We looked for one throat, one voice box, one titanic body to attach to this impossible sound. But what if that's not the answer? What if the sound isn't the call of one thing, but the noise of everything? What if it's not a monologue, but a chorus, sung by a choir of new and terrible life? Let's break it down. Listen to that deep, low-frequency rumble, the part that vibrates right in your chest. Could that be the sound of the plastivore sharks, their polymer-laced hides grinding against each other as a pack moves through the deep? Imagine the acoustic signature of hundreds of armored bodies, a living avalanche of biological ceramic, moving as one through the abyss. It wouldn't be a call. It would be the simple, terrifying sound of their existence, of their passage through the dark. And what about that higher-pitched, almost mournful cry that echoes within the main sound? Could that be the resonance of the Sargassum Citadel? A continent of living tissue, laced with hollow chambers and water channels, would act as a massive, organic cathedral. The currents moving through it, the very pulse of the ocean, could create a standing wave, a deep, resonant hum. It would be the sound of a living island breathing, its voice the wind in its own biological architecture. Then there is the strangest part of the signal, the rapid, rhythmic, almost intelligent-seeming pulses. We've been searching for a vocal cord, but maybe we should have been looking for a signal processor. Is it possible we're hearing the acoustic ghost of the cephalopod collective? Their language is light, but any high-speed biological network on that scale, 1,000 brains firing in perfect sync, 1,000 bodies flashing complex data, might produce secondary effects. A faint electromagnetic field, a subtle pressure wave, a rhythmic hum that is the byproduct of pure, silent thought. Even the grinding, metallic edge of the sound finds a potential home in this new world. It's the sound of the geothermal fungi, the living crystals, expanding across the seafloor. It's the geological scale noise of a life form that is part fungus, part mineral. As it slowly, inexorably grows, its crystalline structure fracturing and reforming under immense pressure. It's the sound of a mountain range coming to life, the groan of a new kind of geology being born in the dark. You see, none of these things alone might explain the full complexity of the sound. But together, a chorus of grinding armor, a breathing island, a thinking network, and a living mountain range. All of them born from the same crucible, all interconnected by the same polluted water. Suddenly, the strange, multifaceted sound begins to make a terrifying kind of sense. We haven't been hearing a creature. We've been hearing an ecosystem. This is the ultimate, chilling conclusion. The sound is not the voice of something in the ocean. It is the voice of the ocean, changing. It is the hum of a new, planetary-scale machine coming online. The hunter made of our trash, the island that eats our poison, the mind that watches us from the dark. They are not separate entities. They are the organs of a new, larger being. The planet's ocean, our planet's lifeblood, is responding to the wounds we have inflicted upon it by becoming something else, something alive, something whole. Is it hostile? Is it intelligent in a way we can understand? Probably not. Those are human concepts. This new entity, this living ocean, would likely be as indifferent to us as we are to the bacteria on our skin. We are simply part of its environment, a source of strange chemistry, a noisy, fleeting phenomenon on its dry land. The horror is not that it wants to destroy us, but that we may not matter to it at all. We have been the dominant force on this planet for so long, but we may have just accidentally midwifed our successor. We started this journey wanting to know what the future of the ocean will look like. We've been scanning the horizon, looking for the shape of things to come, trying to predict and control what happens next. But maybe our role is changing. Maybe the time for looking is over. The sound is still there, pulsing in the deep. It's a message, a signal, a voice. The voice of a new world being born from the ruins of the old one. Perhaps it's finally time we stopped talking and started to listen.